It looks like that. Oh. Perfect. Okay, so Drupal as a linked open data CMS. So to get started, maybe I'll just first give you a bit of context around why I started this whole journey into linked data. And well, I was already a Drupal developer for quite some years before I got involved in an old Drupal 6 project that was somewhere in, it was something that nobody wanted to work on anymore because it had huge aggregated complexity over the years. It had been built upon and built upon. And it was actually the code base, the quality of the code was really well. It was built by really competent people, but just the overall complexity went over the top due to just years of change requests and layers on top. One of the biggest issues in this website was the import and export of data. So due to some on one part legal, but also for interoperability reasons. So the project had to import data and export it back into a certain data format, which is ADMS. I'll mention it later on as well. But these importers and exporters that were used in the project introduced a whole lot of complexity. The data model of what should be on the import side and the website and back to the export side, they started drifting away. So because due to change requests, the nodes on the Drupal 6 side, they had properties got changed and they diverged from the importer. So it was a huge complexity to try to mix and match what was on the source side in the internal domain model and at the source side of the export. So that just to give you a quick overview of what got me into this whole linked data realm, let's say. So who am I? I'm Sander van Dooren. I've been working at Aussie for the last 6-7 years, and the last 2.5 years I've been working at the European Commission in Brussels. There are quite a few people here, my colleagues in the audience. Yeah, so that's the last 2 years, I think, I've been working on this project. It's almost been 2 years. So it's also a complex project in this whole overhaul to the Drupal 8 version of this site. A quick slide on the company. Aussie is a consultancy company. We have another brand that is doing, that is a web agency called One Agency. That's where I come from. And after a while, I decided to go in consultancy. So Drupal is a linked open data CMS. It's there are many things that you have to be aware of before we can have a look at how to integrate linked data into Drupal. I'll start with an introduction on what RDF is. So RDF is the language that powers the linked data, let's say. How we can build data models with RDF, and how we can query those data models. And then now we can integrate linked data in Drupal and put these RDF data models to use. And then some quick highlight of what I see as potential reuse and opportunities for the future. How you could reuse the module that we built, because we built a module to integrate all of this for Drupal 8. So a quick reminder first, before I dive into RDF, on the promise of the semantic web. Back in 2011, there was a big hype about the semantic web, and it was going to change the future, and then nobody heard of it again. So the promise was that if you add markup to your web pages, machines can read, the computers can read this marked up data, this microdata in your pages, and they can extract this data and put them to use to navigate and discover highly connected data on the web. So by putting microdata on your page, you avoid having to write web scrapers, for instance. It would imagine that all the real estate websites would have microdata. It would completely remove the data model for an EmoWeb or a Zimo. They would be competed out of business because it would be trivial to aggregate the data of all the real estate agencies, for instance. So I'm not here to tell you that we should outcompete those aggregating sites, but that was the promise of RDF. If you put semantics in your web page, it's easy to extract them and put the knowledge at work. The downstream goal of linked data is that it will enable on the long term a web of intelligent agents. So through machine learning algorithms, machines can learn, pick up from the semantics of web pages, and it will be would be much easier to integrate existing knowledge sources into creative new forms of this, restructure this data in new mashups. All of this needs standards to work, and that is what the resource description framework is for, so RDF is exactly that. But I don't want to be talking too much about this, about how to embed microdata in web pages. It has its use, and especially if ever we want to get rid of Google as the all-knowing source of knowledge, if we want to be able to have an insight in this data ourselves, it certainly has its use. But I want to take another approach at RDF here, as RDF as data model for your website. So really using RDF as the native way to structure data for your website, instead of using it as a way to represent your data model in HTML at the presentation layer, let's say. So first of all, I want to introduce RDF, how it works, and what the basic semantics are of RDF. And the big target of this is to strive for interoperability. Interoperability is maybe a word that you don't use every day. For us on the JoinUp, it's part of the daily lingo. But the idea is that by exchanging data models, if you and I agree on a certain way of representing data, we can exchange data in this format, and we have interoperability between us. So the more people agree on common ways to represent data, the more interoperability and the easier it gets to exchange data. This also explains a bit why the European Commission is invested in this. Of course, they have to get a whole lot of countries to agree on standards, and the easier it gets for them to integrate data, the less it costs to integrate, and the end goal for them is to reduce the cost of software development by having shared data models. So towards RDF, I want to have a first look at a traditional way of representing data. This way is just the tabular form of data. I made 2 examples here I'm quite a beer enthusiast. So the first one, the first row that you see here are typically the headers of the data. So they're what you would use to identify what the column data is about. And then the first column of the data is typically your identifier. That's how you use tabular data. It's nothing new. I'll reflect back to this data throughout some more examples. It's just so that to establish a link between multiple representation formats. A bit more a typical way of representing data, and a way that you might enjoy a bit more than having to parse Excel files is JSON, of course. This way we have key value data, we have the beer group, which contains 2 beers, we have Stella, and we have the apt12, both with their value pairs, the brewery, the alcohol by volume data, and the beer style. And this is a typical way that data is represented through APIs. Or if we transform this back into natural language, I'm doing this to get to a point. I'm not trying to annoy you with JSON data. In natural language, we would say that apt12 is a beer. It is brewed by Sint Bernardus. It has an alcohol content of 10%, and it uses a brewing style called Belgian Dark Abbey beer. And this transforms really nicely to the way that we represent data in RDF. So I'll flip back and forth to this slide and the next slide a few times. So when we look at RDF data, it follows exactly the same pattern. It might be a bit less readable, but the first element of this is, if you look at the row with the arrow, the first element that you see is the subject of the triple, because that's what a base element in RDF is called. So the subject is really what we see here. It is losing the microphone. The subject is the app12 here. And if we look at the RDF data, we now represent it through a URL. The second part of the triple is the predicate, which is what in the previous slide you would see as is represented by in the natural language. You wouldn't say RDF type, which means has the type has of type beer. You wouldn't typically, I mean, it makes a bit of a weird sentence, but when we skip back, you will see that it is the highlighted part here. It really is the thing that you're talking about. So the app12 is brewed by Sint Bernardus, and then the last part is also a URI in this case, which is the beer type. So this is the basic structure of an RDF triple. It contains a subject, predicate, and an object, and this way we can represent a whole, every imaginable data that you could represent in JSON or a tabular data format. It's really just a way of representing data. Now, what composes a triple? At the first part, our subject is always a URI. It really uses the core of the web, let's say. The basic infrastructure of the web is links, and we use this for both the subject, predicate, and the object. So with these simple three things, we can describe all sorts of data. The only exception that we have is the object. An object can be presented, can be a URI as well. This is the case when you would have in Drupal, for instance, an entity reference. When you point to some other entity, you would use a URI as the value of the thing. When it is really a value of text, for instance, when you have a text field in your entity, it would be called a literal in our case. And a blank note is a bit of a special exception. It is sort of an anonymous URI. It is something that is not named explicitly, but is an implied identifier. I won't be talking about this. We won't use these blank notes for any further. Also because our module doesn't support them yet. So you don't really need them to already have a really expressive data model. It's just for some things, and I'll get back to that later, you might have a use for those. So what we really express here is something is expressed by something else. Or for instance, up 12 is brewed by St. Bernardus. So if we look at the Drupal side of things, our subject would correspond to an entity ID. Our predicate would be a field name, typically. So it's your normal body field, for instance, and the object would be your field value. So when you start looking into RDF, the end goal is to describe your entities. It's your articles, your news on your website. It is just a way of representing data. The format itself has a certain mathematical elegance in it. I mean, it's the simplicity kind of makes it beautiful in a mathematical sense. I mean, if you have any love for mathematics, you might find beauty in some expressions, and I find this certainly true for RDF. It makes an elegant way of expressing data. If you want to know more about RDF as such, and you really want to dive in, I can highly recommend the RDF primer, which is W3C documentation, which might not be your average source of documentation. Normally, if you have to go back to the W3C pages, you're already at the edge of despair, probably. But in this case, it's really a nice introduction on the subject, and it's one of the better sources of data out there. So what you can find there, and what I won't touch upon further in the presentation, is ways to make distinctions between multiple data types in literals. So if your object has a certain, if it's an integer or a date or these kinds of things, the data types are described there, as well as how to do translations with this thing, which is something that an average Belgian Drupal site can have some use for. So why would you bother? It's a good question. One of the main reasons that I see for using RDF as a data model is that by definition all your entities are uniquely identifiable. If you want to have the same, for instance, if you're doing content staging with Drupal, you would have to, I mean, it's already quite a lot better now with Drupal 8. You have native UIDs for all your entities, but still having unique identifiers for every single entity in your system is a big win for data exchange if you want to exchange with your downstream website, for instance, if you're doing content staging, or during migration projects or whatnot. So there is also a really nice separation of the concept of RDF and the way you represent it. There are many ways to represent RDF content, for instance, through XML, through JSON as well. There is an extension to JSON that is called JSON-LD. You can upgrade your JSON file to JSON-LD by putting a header in there. So if you want to get involved in linked data in a really cheap way and you want to upgrade your APIs, you could do so by just outputting a header in your response, which would point to a small document that makes the links from your keys to predicate mappings, so that the consumer of your API can use it either just as plain JSON or as JSON-LD. Of course, there is the ease of integration. If you saw the list of triples for beer, for instance, you can just concatenate it. If you have multiple sources of data, you can just throw all of them in one file, import them into an RDF database. You can start querying it. And another major thing is the standardization level. If you use other types of databases, if you use a Neo4j or a Postgres or I don't know, a document database like a MongoDB, they all work great, but they lack the level of standardization. The data that you put in there, if you want to move it back out, you will always have to write code just to get your data back out into a format that some other application can use. And this is something that you can completely avoid by using RDF as your data model. It just abstracts away these differences because it's a standard, and all the implementers just implement the standard, and this way you get data portability through multiple vendors, which is of course a big win if you want to try to avoid vendor lock-in. Of course, if you have just a blob of data, it doesn't make a lot of sense. You can freely express yourself through these triples, but at some point, if you want to start exchanging them, you will have to agree upon a data model, and that's what I want to talk about next, is how you can start putting some meaning into this list of triples and how you can start grouping them into data models. And then, of course, start querying them, because what's data if it can't answer you any questions? So on top of RDF is really a bit of a layered architecture, in that sense that there are standards that just plug on top of the core RDF specification. And the first layer on top, let's say, is RDFS, and RDFS is a way to build schemas in RDF. This allows you to build your classes and your properties, what you would do in Drupal, typically by side building and then exporting into YAML files. So you can, in RDFS, you can, through triples, describe that this certain thing expresses a class and that it has certain properties, and this file where you describe your model in, you can give it to other people and they can reuse this file of this schema to build the same build data in the same format, and then you can exchange data. That's more or less the idea of having a schema. One of the major advantages of this is that it will eventually lead to you building ontologies instead of building simple data models. Now, what is the big difference between an ontology and a data model? An ontology allows you to reason over properties. So, for instance, if I have a class that describes a person, and a person has a child, for instance, I can have and this clause points to the data points to a certain other person. I can infer from this model that the child therefore must have a parent which is the opposite relation of this model. So that's also something that you can describe with RDFS, is these inverse properties that allow you to really make your data a whole lot more expressive. And in the long run allows you to reason over properties and infer new triples with a specific technical solution that is built into some databases. Enough of that. So the basic property in RDFS is defined in this way. You define that something has a domain and a range, and this way you can define class membership. That's it. Once you start building models, a really common thing you want to do is, we have this in Drupal as well, you can build nodes, you can build content types, but there is also something, sometimes a need for just classifications, and in Drupal we use taxonomies. This isn't any different in RDF models, and that's why there is a shared RDF schema that people use to describe taxonomies, and that is SKOS. So it stands for the Simple Knowledge Organization Schema, if I'm not mistaken, and it allows you to just express hierarchical data with terms like you would do in a typical Drupal taxonomy. Another really good source, if you want to get started with RDF as your data model, is schema.org. Their end goal might be a bit different. Their goal is really it's a consortium of the Googles and the Microsofts out there. Their goal is to have a way to describe data so that you can annotate your data in HTML, so that the Googles can parse this data and discover that your event is taking place at a certain time, and they can provision those small info boxes that you get when you search for certain types of data. So their end goal is a bit different. They just want to use it to enrich your research experience, and for them to have an easy way to get your data. But it can also be a really good source for to look at if you want to model, if you get into a new business domain. For instance, I have no idea what a typical restaurant data model would look like. It's really easy, even if you don't use RDF. If you go to schema.org, they describe a restaurant that's having opening hours, it has a menu, it has all the typical things that a restaurant would have. But it's also a good reference source if you want to just get a quick look at, am I not forgetting something in my data model? There are some people out there already using ontologies to exchange data. One of them is, for instance, the SAMIC, which tries to promote interoperability within Europe, and they use it, for instance, they made an ontology for business registries. So when you register a company, you get a VAT number, you have to register your company with an address. All of this data goes into a federal database. Now, if you want to integrate all of these databases on the European level, you could build an API and try to force every country to use your API to register your data, or you could do the reverse, trying to pull all of the data from APIs of these countries in Europe. But this really quickly becomes a complete mess if you have to integrate with many parties. So that's why what they do is they made an ontology to describe business registries. And whenever you start a company, it gets described in this RDF model for businesses. And this way, the Commission can just parse all of the national members' data sources into one European data set so that we have an overview of all the companies in Europe, for instance. A bit more local is the Flemish government. They are turning the location of addresses, which might also be something that you don't use every day, but when you reside at a certain address, this address has a physical location, so it has for a certain commune, you have a street level, you have then an address, and this address has a physical geographical coordinate, and they describe this address data in RDF so that all sorts of government applications can then import this data and reuse it. This is also ported then to the European level so that in the end we can have an overall view of address data. If you are, for instance, a DHL, it might be interesting to know where addresses are. And then there is also other more integration initiatives, for instance, touristic data in Flanders. An example of shared taxonomies might be a list of countries that you can reuse in an application. If everybody uses the same notion of Belgium, it's quite convenient if you reuse data. And of course, when you gather all of this data in your local database, you need a way to query it. There is also a specification for this, and that's the Sparkle language. Sparkle is like SQL, but not entirely. It's more related to the Neo4j kinds of databases. It's graph query language, so you can in fact traverse properties through entities quite easily. If you want to have really nested, complex data, then it performs really well. It is also a W3C standard, which gives you the added benefit again of having the vendor independence. While if you move from MariaDB to Postgres or something, you already have issues because it's a slightly different dialect of SQL. And you can a typical integration way through Sparkle is through public endpoints. So this is more or less just dumping a database connection on the web. It's sort of a REST endpoint that allows you to query a certain database. If you've ever seen the info boxes on Wikipedia, if you go to the page of Belgium, for instance, you will see at the right side on Wikipedia pages these small boxes with amount of inhabitants, grounds, this many of square kilometers of surface, currency used, all of this metadata on a certain entity. This all gets aggregated into a project called DBpedia, and they transform all of this data into an RDF model, and they have a public Sparkle endpoint that you can query. So this is really a gold mine of data. You can just use the endpoint to ask ridiculous questions, traversing the entities stored in Wikipedia, which you typically through just browsing the interface, it would be impossible to answer a question, for instance, like, give me all the writers that wrote a novel in the 1600s and that were married to a woman that was born in Austria, for instance. if you want to answer these kinds of questions, it would take you a ton of research. While if you have these kind of modeled entities and a structured way of representing data, it becomes really trivial to answer these kinds of questions. So that's one way is to answer this data is to use a public endpoint. Of course, if you want to start generating your own content, you will need your own RDF database, and that's where you'll have to set up your own endpoint. What we use in our case is Virtuoso. It's a kind of database. There are many vendors out there. This one is an open source one. And you can just apt-get it in Debian, so if you want to get started, it's quite easy. Now, all of this to get to the point of linked data in Drupal. Of course, when we have this public Sparkle or private Sparkle endpoints, we still have to build web forms on top of it, and as we are used to using Drupal is for us a nice way to expose this. So what we did is for our project we built a module that integrates with this Sparkle endpoint and allows us to query RDF data in this way. To give you a bit of context what we're doing and why we needed all of this, we're building a website called JoinUp. It's a community website that tries to promote reuse of software within Europe. So if one member state makes software, open source software, for instance, for doing EID transactions, other member states might benefit from this. So JoinUp is a site that tries to promote across administrations open source software and standards. So its target audience is more or less public administrations and people working for public administrations. It's really trying to do a bit of community building around these software projects. So news events that are formed around software projects or standards, and it's not a GitHub clone, but it's the method layer on top, let's say. So why RDF? We have to aggregate data from other kind of instances. Local levels might have open source software in their data portal, in their website. By describing this data in RDF, we can federate it from federal governments, but in turn they might federate it from, I can imagine that in Belgium we would have a Flanders portal, a Walloon portal, and a Brussels portal to be able to have these complex integration models. RDF is really a nice way of federating this data up the tree, let's say. So what we did, I don't know if people are using domain-driven design here. We really went with a conformist pattern that was from the lessons learned from the old website. We really try to stick to the standard as close as possible. We don't make any exceptions, so if people ask for, can you add, make this field multi-valued, and in the specification it is single-valued, we simply say no because it's not allowed by the specification. In the previous website, the temptation was a lot bigger to make the change and go with it. So now that we really use this RDF model at the core of our application, we can no longer make these exceptions, which makes our lives a lot easier. At the out, so we federate data, we store it internally. We also have things that are content generated locally in our platform, At the other side of the platform, we ourselves have an endpoint that people can query to get the data back out of JoinUp if they want to daisy chain the platform into a worldwide platform, for instance. So the idea is also that you can reinstall this platform on the local level, and this way that information can really bubble up through many levels of governments. I'm going to quickly skip through this and have a look at the module itself because we're running out of time. What does our Drupal module do? It maps RDF in the database layer to Drupal objects, entities. We built a database layer for this, so you can save and load and save entities from the Drupal store. You can also query them through the entity query layer that Drupal has. So we have completely abstracted this RDF model in Drupal at the infrastructure layer, let's say. So the database layer takes care of all of the RDF stuff, and at the business layer we don't have to worry about Sparkle queries or anything RDF related. We can just use Drupal entities and make entity references and use Drupal as you would normally do it. What we also did is, after we had this storage layer where we can load and save things, we also swapped out the whole storage class of the taxonomy module, so that now we're no longer storing taxonomy terms in database tables in MySQL. We're now storing taxonomy terms into a SCOS ontology in the Drupal store database. So this gives us a huge benefit, because in the commission there are like a lot of predefined vocabularies that are reused throughout all departments. For instance, the list of countries, currencies, things that we policy domains, things that make sense within the business of the European Commission. And SCOS really helps there, so that we can just dump it in the Drupal store and reuse it. What is also working at the moment in the module is translations, multi-graph support. So if you have a list of triples, for instance, it is by default not possible to have revisions. You don't have a revision table in a Drupal store. What you do have is graphs, where you can group chunks of triples in and give them, like a collection of triples goes in a graph. And with this way we can, by having support for multiple graphs, we can fake revisions by having a draft graph and a published graph. And when an entity gets published, we move it from the draft graph to the published graph, and that's the way we have poor man's revisioning. I'll quickly, because we're really running out of time now, show you what the mapping, how we map data in Drupal to properties. So our module provides us with an entity type, which is called RDF entity. We can make new bundles in here, and on these bundles we can then map properties, the base fields of the entity, as well as the fields that you would that you typically add through the interface. So as you see here, we have a collection, and on a certain field, if I go to the storage settings, you'll see here that we have a mapping. Oh.
Next.
Okay. In the mapping, we have our values mapped to these predicates of the Drupal, so that when we load and save things, Drupal knows which predicate to use and how to serialize the data back out. I'm working on an experimental module that would automate all of this by having, if you have described your ontology in RDFS, if you have made this description of your data model, that you would simply be able to drop your RDFS file on your Drupal site. Then it could already pre-generate all of the entities for you because you already did the modeling work, and this way you would have a plug-and-play module that allows you to just drop a model in there. For instance, if you would point this to the DBpedia endpoint, you could then take some classes of DBpedia, like person, drop it on the site. Person would get modeled, and you would have a list of all you would have all the person entities available in Wikipedia in your Drupal site, available for referencing. For instance, if you want to reference people in an article, you could just point them, or if you want to show Wikipedia articles inline in your website, you could just pull in all of the knowledge of Wikipedia in your Drupal website, which is kind of cool in my opinion. But so that's more or less what it looks like on the front end. It's just a Drupal website, so this is really only on the storage side you will see these things. On the structure, yeah. Maybe I'll stop with this because the base properties look more or less the same. Are there any questions about this as we're running out of time? Yes.
You were saying that there's like a set of taxonomies you can copy from another place, but is there like one centralized REF database in the European Commission?
There is no centralized database, but well, there is a centralized place where you can find them. It's on the page of the publication office. They have the metadata repository on their website. So if you search for the publication office of the European Commission, go to the metadata registry. They have a list of all these taxonomies with countries, currencies.
But if one country changes, you have to copy to all the applications again?
Yes, you have to update it in the individual applications, yes. But it isn't, it is not as much as an issue as you would expect it to be, as the URIs are still stable. So the notion of if a country would change its name, for instance, if it's just a change of name, it's still pointing to the same subject. So all the references are still intact. You don't have any integrity issues with on that level. So, other questions? Yes.
So you're using Virtuoso.
Yep.
Connects on like something like DBpedia. And then you're using RDF entity to map what's in Virtuoso with.
In case of the DBpedia example, so what RDF entity does is it just connects to a Sparkle endpoint. It can be your local Virtuoso install, or it can be a remote thing. So there is, in the case of DBpedia, there is no intermediate need for. You can directly point it to, you don't need anything locally, you can just point the connector to the endpoint of DBpedia and start pulling in. In the end, it's just it's like a web service where you can query all the data of, and by modeling them by modeling the entities locally as they are in DBpedia, you can also follow the entity references from one thing to the other, and it will.
How do you query? Is there a Sparkle query?
Yes. So what our module does is it will translate all of the typical entity queries of Drupal into Sparkle queries underlying. So we really made the whole database layer that translates all of the. If you put a condition on the entity query, it will translate it to a Sparkle query, and It really, in the application itself, you just have to do the mapping, and then it behaves like a normal Drupal website. Okay, I'm gonna toggle this back. So because we don't, just one last thing, because we don't have, because we have two backends, we have news in MySQL, other entities in Virtuoso. We use Solr to index everything, and we just run most of our queries against our Solr index and then load back from them. So that if you were wondering how we do cross joins between the databases, that's it. Okay, time's up. If you have other questions later on, I'll be around. So don't hesitate to get back to me. Thank you.